So as we started identifying this, we go, my God, we found this big pathway that's driving all these, this fructose pathway is involved in how salt works, how glycemic carbs work, how sugar works, and it's driving this series of diseases. And we realized, and we just had a paper come out, I think maybe some of you have seen it, because it's had a lot of press, but we think that this pathway can explain Alzheimer's disease and actually bipolar disorder and some of the things that we heard about earlier today. So just to quickly wrap up on this, Alzheimer's disease is associated with these amyloid plaques, these neurofibrillary tangles containing tau protein, and you get this cerebral atrophy. And everyone who's been trying to figure out how to treat Alzheimer's, have focused on these amyloid plaques. And yet, despite 40 or 50 different drugs that have come out, only 1 or 2 have been approved, and they don't work that well. It's like we're missing something. And so people started thinking, well, maybe what happens in early Alzheimer's? What happens before you get the amyloid protein? And there are 3 things that have been identified. There's insulin resistance in the brain, there's inflammation in the brain, and there's mitochondrial dysfunction, a low ATP production, a drop in ATP, and that is the biosignature of fructose. That is exactly what fructose does. So the question is, could fructose have a role in Alzheimer's disease? And when you look at the risk factors for Alzheimer's disease, it's diabetes, obesity, sugary beverages, high salt diets, very strong, high glycemic carbs, very strong. All of these are associated with fructose production. And if you do studies, like from the Framingham, you'll find that sugar intake directly has effects on short and long-term memory based on how many soft drinks people are drinking. And it's associated with a reduction in brain volume with soft drinks and hippocampal volume, which is the area of the brain that handles recent memory. So how would fructose cause Alzheimer's disease? So remember that fructose induces a foraging response. Foraging is like what's key. And for an animal, when it forages, it has to change its behavior. There's an urgency. They have to find the food quickly. So there's an increase in locomotor activity. They have to be moving rapidly. They have to be able to take risks. They have to have a quick reaction time. They can't deliberate. They have to make quick decisions. It's like you're going through, and you have to be brave. You have to go into these areas. Being a scout or, foraging, you're a hero. It's a hero's thing. But it requires these behaviors. You don't want to have a lot of self-control. You don't want to deliberate a lot because you've got to make decisions quickly. So it turns out that fructose does this by working on the insulin-sensitive regions of the brain. And what it does is it's actually been shown that fructose will inhibit, a lot of it is inhibiting cortical activity. So cortical blood flow goes down when you eat fructose. And it goes straight to the brain, the areas that are involved in self-control. And it reduces blood flow to the hippocampus. And the hippocampus is where recent memory is, because it doesn't want you to remember that there was a predator there. It wants you to still go in. And and then on contrast, it stimulates like visual cues so you can see the food. It stimulates an area of the brain called the anterior cingulate, which is involved in foraging. So fructose does all these things by suppressing there's a lot of inhibition of cortical activity. And so if you give glucose, you get the opposite. Glucose actually acutely, this is in the first 10 minutes before glucose can be converted to fructose. When you give glucose acutely to a human, blood flow goes up to the brain in the cortex. But you give fructose acutely to a human, blood flow goes down. And it turns out that foraging requires inhibition of the temporal lobe, the prefrontal lobe, the posterior cingulate. These are all to help you. This is all the way fructose stimulates foraging. And it reduces the energy required by the brain. Remember, the brain takes 20% of all energy? Foraging is a beautiful way because it reduces that significantly by inhibiting these areas that are involved in control. And guess what? The areas that fructose inhibits are the same regions of the brain where Alzheimer's develops. And the areas that fructose spares tend to be the areas where, that are spared in Alzheimer's. There's a direct relationship. And when you look in the brains of Alzheimer's patients, fructose levels are super high. And so is sorbitol. The brain is making fructose. And if you give a high glycemic food, or if you raise blood glucose in a human, you can measure the immediate rise of fructose in the brain. This was done by Sherwin at Yale. So that's human data. So we're making fructose, and fructose is dropping the ATP levels in our brain. And you can see that ATP levels fall in the brains of Alzheimer's patients. And so the risk factors for Alzheimer's stimulate fructose in the brain. Fructose induces, it's basically a foraging response. It's driving insulin resistance in the brain, which I didn't show you, mitochondrial dysfunction, inflammation. That's all now been shown with fructose, with models of Alzheimer's and also in Alzheimer's. And then you get the amyloid plaque. And if you give fructose long enough to a rat, they get amyloid and tau protein in their brain. So in summary, there's been a huge increase in sugar. This has led to excessive fructose intake. Its stimulant was meant to be a survival mechanism, but if you overdo it, and that not just from the fructose we eat, but from the fructose we make, you can get dementia, obesity, fatty liver, dyslipidemia, diabetes, cardiovascular disease, hypertension, stroke. And there's even a pathway through the Warburg effect to stimulate cancer growth.